Still in section 1.5, here, finding asymptotes. Now we looked at that graphically, but algebraically, for the most part, what we're looking for is look for division by 0. Okay, and an obvious case, I'm going to call it, obvious case of an asymptote is some constant k that's not equal to 0 over 0. Okay, so if I look at a function and by direct substitution I get something like this, k over 0, substitution here, then I probably have an asymptote there. Now, and sometimes it might be more difficult to see something like that, but generally, if that's what's going on, that's an obvious case. And so if I just have your basic rational function, and I had something like x squared plus 3 over x minus 2, then we see that x minus 2 equals 0 at x equals 2, and direct substitution direct substitution gives 7 over 0. So I am very sure that we have a vertical asymptote at 2. Now, what do you do to check that? Well, look at it graphically. Okay, oops, x equals c, 2. Okay, vertical asymptote at x equals 2, look at it graphically and we can see that that's the case. And so that's all you're looking for. If you have like g of x is the sine of x over the cosine of x, well, at certain places it's pretty obvious what's going on, right? Is that cosine of x equals 0 at x equals 0, pi, 2 pi, etc. But also x equals negative pi, negative 2 pi, and so forth. Oops, cosine. Scratch that. Sorry. I could hear you all yelling at me even in the video. So cosine of x equals 0 at x equals pi over 2, at 3 pi over 2, 5 pi over 2, and so forth, but also the negatives of that. Negative pi over 2, negative 3 pi over 2, and so on. But sine is either 1 or negative 1 at all those. So, we would either get by direct substitution Okay, so by direct substitution, we get, either 1 or negative 1 over 0. And so we're going to have vertical asymptotes at all those values of x. And of course sine over cosine is also can be named the tangent function, and we know that that's what happens with the tangent of x. And so when we have a constant that's not 0 over 0, then it's pretty obvious we're going to have a vertical asymptote. Now, what's harder is 0 over 0, because it's not so obvious. And cases like that are, say, for instance, sine, so h of x equals sine of x over x. At x equals 0, this looks like zero over 0. And, so in that case, well, 0 over 0, is there a vertical asymptote there? Well, if you graph it, the answer is no. Okay, so this has no vertical asymptote. Okay, so you would get something like that, but on the other hand, if you have let's see, what else could we do? Well, if we change it to instead, what if we look at sine of x over x squared? Okay, well, at x equals 0, this implies 0 over 0 again. Okay, but if you graph this, you will find a vertical asymptote. Okay, a vertical asymptote at x equals 0. Okay, so when you get 0 over 0, it's not so obvious, because we have these two things that look very similar. One has a vertical asymptote, one does not. My suggestion is you look at the graph for now. Once we know some calculus, we have tools to attack it that way, but without those tools, pretty much it's a numerical thing, and typically the easiest way to do numerical things is just to graph them and do them graphically, because we can get a lot more information visually. Alrighty, so that is the idea of trying to find these asymptotes and where the limit might be either positive infinity or negative infinity. Okay, we'll call that one done.